Hello children, welcome to this class. In this class you're going to be learning multiples and lowest common multiples, which is sometimes called LCM. First, let's look at the meaning of multiples. What is a multiple? A multiple is a number that can be divided by another number without a remainder. For example, 10 divided by 2 is exactly 5. Therefore, 2 is a factor of 10. We've already learned that from the previous lesson. And 10 is a multiple of 2. That means whenever you divide a number by another number, the divisor is the factor and the dividend is the multiple. Similarly, 10 divided by 5 is exactly 2. Therefore, 5 is a factor of 10 and 10 is a multiple of 5. Now let's look at common multiples. What is a common multiple? Well, a common multiple is a number that can be divided by 2 or more numbers without a remainder. For example, 12 divided by 2 is exactly 6. 12 again divided by 3 is exactly 4. 12 divided by 4 is exactly 3. 12 divided by 6 is exactly 2. This means 2, 3, 4, and 6 are all factors of 12. Then 12 becomes a common multiple of 2, 3, 4, and 6. Now let's look at lowest common multiples or least common multiples, which is sometimes called LCM. Now what is LCM? Well, this is the smallest number that can be divided by a set of numbers without a remainder, or the smallest number that can be divided by 2 or more numbers without a remainder. Now we are going to look at how to form our multiples by multiplication. We are going to be looking at how to form multiples by simply multiplying the number by consecutive whole numbers. Now, in our first example, we are going to be looking at how to form multiples of 3 and 5. So, we are expected to find the first 5 multiples of 3 and 5 in our first example. Now let's look at the solution. Multiples of 3. Well, the first whole number, positive whole number, is 1. So 3 multiplied by 1 is 3. 3 multiplied by 1 is 3. Alright? 3 multiplied by 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. So these are the first 5 multiples of 3. 3, 6, 9, 12, and 15. Now let's look at multiples of 5. Similarly, we multiply by 1, 2, 3, 4, and 5. The first one is 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. Well, the first 5 multiples of 5 are 5, 10, 15, 20, and 25. So it's very easy to form your multiples. Alright? Okay. Now we are going to look at the second example. The second example, number 2, we are asked to find the LCM of first 15 and 18. What is the lowest common multiple of 15 and 18? Then after that, we will also look at the triple numbers here. We have 24, 32, and 45. Alright, now let's look at the solution to question number 2. Well, 2a, we are asked to find the lowest common multiple of 15 and 18. And we are going to be using the prime factorization method. We have already learned what prime factors are and how to prime factorize. We are going to be applying this rule in solving LCM of 15 and 18. Now look at the set of the table method. You see 15 and 18. The lowest prime number or factor that can divide either of the number 15 or 18 is 2. When you look at it, 18 can be divided by 2 because it's an even number, but 15 cannot. So what do? We divide 18 and get a 9, but bring down 15 because we cannot divide it by 2. Alright? Now we move to the next line. We look at 15 and 9. We know that 3 is the smallest number that can divide 9 and now can also divide 15. Well, 3 into 15, you get a 5. 3 into 15 is a 5. 3 into 9 is a 3. Alright? Now we come back and look at the 3 and the 5. Because 3 is there, we are going to put down another 3 and start dividing. 3 into 3 is a 1. 3 into 5, well, we know 3 cannot divide 5, so we bring down 5. So you must have noticed that when you cannot divide a number, you bring that number down. Now we have 5 and a 1, so we put down a 5. 5 into 5 is 1. And since we cannot divide this 1, we bring down 1. Alright? So now we have 1 and 1. 1 and 1. So we stop dividing and look at our prime factors. These prime factors will give us the LCM of 15 and 18. Now what we do is to multiply the prime factors. 2 times 3 times 3 times 5. That is the same thing as 9 times 10. And that gives us 19. So, what is the LCM, or the lowest common multiple of 15 and 18? It is simply 90. So, this is how we use the prime factorization method or table method to solve LCM. Alright, now let's look at the next question. 2b, to find the LCM of 24, 32, and 45. So that becomes question 2b. 2b. Now the same prime factorization method or table method. Now let's look at it. We have our 24, 32, and 45. 24 and 32 can be divided by 2, but 45 cannot. So when we do that, we have 12 and 16, but 45 is brought down because we cannot divide it. Then we have to put another 2 because 12 and 16 can be divided by 2. Now 2 into 12 is 6. 2 into 16 is 8. 45 cannot be divided by 2. We bring it down again. Alright. And because we have 6 and 8, we put down another 2. Now this 2 divide 6 gives us a 3. 2 divide 8 gives us a 4. But 45 cannot be divided by 2. We bring down 45 again. Down. Because of the 4, we put down another 2. 2 cannot divide 3. We bring down 3. 2 into 4 is 2. Bring down 45. Because of these 2, we put down another 2. Alright? 2 into 3, well, cannot. We bring down 3. 2 into 2 is 1. Bring down 45. Now we bring down 3 this time. Now 3 can divide 3 and gives us a 1. Bring down 1 and divide 45 to get 15. Well, we now have 15 left. We know 3 can once again divide 15. So put down another 3. 3 into 15 is of 5. Then we bring down the ones. Okay? And finally, we look at 5. We know 5 is the only number that can divide it because it's a prime number. So 5 into 5 gives us a 1. And the other 2 ones are brought down. So what do you notice? We have 1, 1, 1. So we cannot continue dividing. Now you look at your prime factors. Alright? Then you are going to multiply these numbers to get your LCM. So to solve LCM, you must have good knowledge of your multiplication table. Alright? So let's multiply. Well, the first 2 times the last 5 will give us a 10. I want you to see how we got these numbers. The first 2 times the last 5 gives us a 10. Then to get a 12, 2 times 2 is a 4, times 1, 3 gives us a 12. That's 3 times 4, 12. Then the remaining 2 times the last 3 will give us another 12. You see? So we are going to have 12 times 12, 24, 144, pardon. 144 times 10, 1440. Alright? So the LCM of 24, 32, and 45 is 1440. Alright, it's time to look at the last question. Now, that is question number 3. Find the product of the HCF and the LCM of these numbers. What are the numbers? 12 and 15. What that simply means is that you will find the LCM, you find the HCF, and then multiply your result because they said the product. So when they say product, it means you must multiply your result. Okay? Now, first, we are going to look at the LCM. What is the LCM of 12 and 15? Following the same table method of prime factorization, we are going to get 2 into 12, 6. 2 into 15, 15, because we cannot divide. 2 into 6, 3. Into 15, 15. Well, now it's 3. 3 into 3, 1. 3 into 15, 5. Then we use 5. 5 into 5 is 1. So we have 1, 1. And we therefore multiply our prime factors, which is 2 times 2 times 3 times 5. Well, that is simply going to be 12 times 5. That is 60. So the LCM of 12 and 15 is 60. Now let's look at the HCF. HCF of 12 and 15. Well, again, when we follow the table method of this, we discover that 2 can divide 12. 2 can divide what? 12. If 2 can divide 12, we are going to have 4. Sorry, 3 divide 12. We are going to have 4. Now that same 3 can divide 15, and that will give us 5. So in HCF, recall that when we are doing our HCF, we simply divide with the same number. And when we can no longer divide, we stop. Unlike LCM, that we must get to 1, 1. Now, because we can no longer divide, HCF is therefore 3. Now, if LCM is 60 and HCF is 3, the product of HCF and LCM will become 3 times 60. If you have done that correctly, you will get 180. 180. So, the product of the LCM and HCF of 12 and 15 is 180. 180. Well, this is how far we can go on this video. I know and I believe you have learned how to find your LCM without much stress. If you have difficulty, you can play this video again. Thanks for watching and see you